Okay, so we are in integration by parts. And I just want to go back before I go forward and talk about some of the problems that we did. We did the integration by parts formula. We said that in order to do it, we have to do u dv is equal to uv minus v du. So our difficult part is to identify u and then identify dv. And for the most part, we need to know how to integrate whatever dv is. Okay, so that's one of the difficult parts about the harder integration. Is to do the harder integration, you got to know the easier integration. Okay, so in order to do some of these problems, you have to know the integral of, I think that's what I put on the other class, and I didn't put that on this class. I did say something in the very beginning. Yeah, I said, what is needed? So knowledge or mastery of integrations of polynomials, trig functions, inverse trig functions, and exponentials. Got to know those things. Okay, and then of course, differentiation of all those other functions. Okay, so we had gone through some of these, and I think we got to using our formula. So we said that when we had x to the n in the integration, we could use our table. Okay, and so the last problem that we got to was this one. And so we used the table on x cubed e to the 2x. Okay, so now I want to try to do, let's see, I'm trying to remember. Man, my brain is like, after I did this. Oh, okay, that's what I did. Yeah. Okay. All right, so most of the problems that you will see will look like x squared, x cubed, all powers of x inside this, but there's a 5% chance that many of the problems don't have x to the n. And when they don't have x to the n, then you can't say x cubed, 3x squared, 6. You can't just go down in the table and get 0. So that 5% of the problems that don't have x to the n are the ones where u is not so easy to find. So I'm going to go back and grab this one, because this is the one I want to do. Okay. So this is in that 5% of the problems where we have to use u as log x, because the only thing dx can be is dv. So by process of elimination for this problem, we're going to let u equal to the natural log of x, and dv has to be dx. Now, how did I come to that conclusion? Because dx and log x are the only two things in the problem, and dx is a differential, so that it has to be dv, which means the only thing left in the problem, which is the log of x, that has to be u. Okay, so what was our formula? Okay, let me just write it again. The integral of u dv is equal to uv minus the integral of v du. Okay, so we're here. So now du is what? What is du?
Is it 1 over x?
Okay, keep going.
Dx.
Yay, okay. 1 over x dx, awesome. And v is equal to x, okay. All right, so let's do it. So we get the integral of the log of x dx is equal to u, which is the natural log of x, times v, which means it's times x, minus the integral of v, which is x, times du, which is 1 over x dx. Well, how nice is that? This is x times the natural log of x minus the integral, and these x's divide out and leave me just the integral of dx, which is just x. So now I get the natural log of x is equal to x times the natural log of x minus that integral is just x, and then now I have a constant. So I'm done. It looked hard, but it turned out to be a very nice problem. Okay, any questions about that? All right, I'm going to go back and I'm going to snatch this tan inverse problem. Oh, no, that's right. I remember I got to type it in myself. I type it in all over again. Okay, so integration, insert. Okay, so here's the integral of tan inverse x dx. All right, so this one is just like the last one. That is, I only have two things in the problem, tan inverse of x and dx. So dx by default has to be dv. And then u has to be the tan inverse of x. All right, so therefore we get u is the tan inverse of x, and dv is dx. Okay, here's the big question. What is du? Oh. What is du?
Is it 1 over what? 1 plus x squared?
Yes, keep going.
Dx.
dx. Okay, and then v again is x. All right, this problem going to need a little bit more space. No, I need more space for this one. Okay. All right. So therefore the integral of the tan inverse, that's going to give me the wrong one. Okay, so the integral of the tan inverse of x dx is going to equal u times v. So u is the tan inverse of x times v, which is x, minus the integral of v, which is x, times du, which is 1 over 1 plus x squared dx. All right, so now I get the integral of the tan inverse of x is equal to x times the tan inverse of x minus the integral of x over 1 plus x squared dx. And now I have to do this integral. Now, if you can't see right away what this integral is, then you have to go off to the side and you have to compute it. All right, so let's compute it. So we have the integral of x over 1 plus x squared dx. All right, so now I'm going to do a normal, simple, basic u substitution. So I'm going to let u equal 1 plus x squared and du equal 2x dx and x dx equal 1/2 du. So this is a basic u substitution. I'm not doing any integration by parts on this integral. It is a basic u substitution integral. So I get the integral of x over 1 plus x squared dx is the integral. Well, x dx is 1/2 du, and 1 plus x squared is u. So this is 1/2 the integral of du over u. Okay, what's that integral? What's that integral? The integral of du over u.
Is that the ln of the absolute value of u?
Yes, it is. So this is 1/2 the natural log of the absolute value of u plus a constant. So I get that this integral turns out to be 1/2 the natural log of the absolute value. U was 1 plus x squared plus a constant. Okay, so now I can finish my problem because I know this. So I can just pop that right in there. And so now I get the integral of the tan inverse of x is equal to x times the tan inverse of x minus 1/2 the natural log of 1 plus x squared plus a constant. Now notice I dropped the absolute values. I'm gonna put my picture back up in a second. I dropped the absolute values because we don't need absolute values on 1 plus x squared because I know it's positive. Okay. All right, so that's the end of that problem. Let me put a nice little box around it because that's the answer. Okay, I hope my sniffles are over. I don't know how many of you had COVID, but that's the one thing that did not go away was the sniffles. Okay. Any questions about that? So those are the strange ones. Okay, and there are a couple of strange ones in the book as well, the book which I showed you online. Okay, all right, so now integration by parts, we can do repeated integration by parts. And I like to call this when the cat chases its tail. Okay, and these problems are repeaters differently than this. So the ones that we did back here, where if we did it, let me see, here was one. When we did the integral with x cubed, And then we ended up with another integral of x squared. And then we did the integral of x squared and we ended up with the integral of x. And then we finally completed. That's not the ones that wrap around. These that we're getting ready to do wrap around. So let me explain what I mean. So we're going to start with this one. Okay, so we're going to start with the integral of e to the x cosine x. Now, in this problem, as you can see, derivatives of and integrals of e to the x all give you e to the x back. E to the x, e to the x, drop down, derivative, e to the x, e to the x. Integrals of cosine are going to give you sines and cosines, and derivatives of cosine are going to give you sines and cosines. So these kind of repeat. So these things that repeat in circular fashion when they're put together in an integral are going to chase their tail. So let's see. So it doesn't matter which one I choose for u, but I'm going to choose u to be e to the x. And whichever one I choose for u on the first go round, I better choose for u on the second go round. So my dv is the cosine of x dx. So my du, we know that's e to the x dx. And my v is negative the sine of x, because that's what it is. Okay. So now we're going to take and do the integral of this. Again, you should know it by now. The integral of u dv is u times v minus the integral of v du. So now u times v is going to give me e to the x times v, which is negative the sine of x. And that is wrong. This is positive. Nobody caught that. Integral cosine is sine. All right.
I have a quick question.
Yes.
How come on this quick sheet, it says the interval of, what's that? Oh, never mind. I thought it said negative. It's fine. Thank you.
Okay, no problem. This is integral. So u times v minus the integral of v, which is the sine of x, du, which is e to the x dx. So now I get e to the x cosine x is equal to e to the x times the sine of x minus the integral of e to the x times the sine of x dx. And when I look at that, I said, I started with e to the x cosine. I now have e to the x sine. That's just as difficult. That's why I'm doing integration by parts on this thing. All right, so now I need to figure out what this integral is, so that once I figure out what this integral is, I can put it back into the formula. So once I figure that integral e to the x sine x out, then I put it back into the formula. So now this starts another u substitution problem. So I get the integral of e to the x sine of x dx. And I'm going to let u equal e to the x and dv equal to the sine of x dx. So du is e to the x and v this time is minus cosine of x. Oh, and I need my dx here. Don't forget that. Okay, any questions so far? Hello?
No.
Okay. All right. So I get the integral of e to the x sine x dx is u times v, which is e to the x times negative cosine x, minus the integral of v, which is negative cosine x du, which is e to the x dx. All righty. So now I get that the integral of e to the x sine x, which is what I'm looking for, dx. So this is what I'm looking for right here. I was looking for this. There it is. Oh, I know what I did last time. Yeah, I really didn't black. The sine of x dx. Okay, so there it is. All right. It is equal to negative e to the x cosine of x. And look at here, minus negative makes plus. And once again, my e to the x cosine x pops up. There it is. There's my e to the x cosine x. It pops up again. Okay, so that means this now goes in there. So I'm going to take this and put it in there. So my original problem, e to the x cosine x dx is equal to e to the x sine x minus what I get for here, which is negative e to the x cosine x plus the integral of e to the x cosine x dx. So now I get the integral of e to the x cosine x dx is equal to, I'm going to distribute the negative. So I'm going to get e to the x, the sine of x plus e to the x, the cosine of x minus, oh, now it's subtracted off this integral that I'm still trying to find. All right, so now let's double back for a moment and think what we have. We started with the integral of e to the x cosine x, and we saw that in order to do it, I need to know the integral of e to the x sine x. So I computed the integral of e to the x sine x, and just like I said, cat chasing its tail, this thing pops back up. E to the x cosine x pops back up. So since that popped back up, I put it back into the equation, and now I have this. So if I add the one integral to the other side, oh my goodness, I get two of them. If I could ever, I think must need another battery or something because I keep losing my mouse. There we go. So now we have two of them. Is equal to e to the x sine x plus e to the x cosine x. And so therefore, my answer is going to equal e to the x sine x plus e to the x cosine x I'm going to have to divide the whole thing by 2. And now I can add on my plus C. Cat chasing its tail. Okay, any questions about that? Okay. All righty, let's try the next one. All right, so we want to start off doing the cosine of the natural log of x. So now if I make u just the cosine of the natural log of x, then I'm integrating the cosine of u, but the problem is du is not going to work because du is going to have a 1 over x in it, which I don't have in the problem. So that obviously cannot work. So one of the things I can see is that I only have 2 things. I have the cosine of the log of x and dx. So if that is dx by itself, then this whole thing must be cosine of log x must be u. So now we're going to let u equal the cosine of the natural log of x. And we want dv to just be dx. Okay, so here's a great question. What is du? Got to use chain rule. What is du?
Do you have to go out and solve it by itself?
Say that again.
Do you have to go out and solve it by itself, like using chain rule?
Yes, we can put the, yes, we can do that. So we take the derivative of the outside function and then multiply that by the derivative of the inside function. What's the outside function?
I think it's negative sine natural log of x, and then it's multiplied by 1 over x dx.
Okay. So what did she do? She took the derivative of the outside function, which was cosine, to sine. So cosine, the derivative of cosine is minus sine. So she took the cosine of the u of x. So she got derivative of that was minus the sine of it. And then she has to take the derivative of the inside function. Remember, it's like taking the derivative, you keep going in layers and peeling the derivatives to find the end. So then she took the derivative of the log of x and got 1 over x dx by chain rule. That is absolutely correct. Okay. Absolutely correct. So now this integral is going to equal u times v. So that's the cosine of the natural log of x times v, which is x, minus the integral of v, which is x, and du is negative sine of the log of x times 1 over x dx. Okay, and no, your eyes do not deceive you. What you find out is these x's divide out. I get negative, negative gives me plus the integral of the sine of the natural log of x plus C. So here we are again. The problem that we were trying to do is now in terms of a new problem that's very much like it. So our goal is to get this new problem under control. All right, so we got to deal with this new problem. So here's the cat chasing its tail. The cat went from cosine of log x to sine of log x. And so now we need to do log sine of log x. And I assume we're going to get cosine log x back. So I do the integral of the sine of the natural log of x dx. Going to let u equal the sine of the log of x. And again, du dv is equal to dx. Okay, so du, somebody give me the derivative again. It's going to be a little different.
Negative cosine natural log x times 1 over x dx.
Okay, excellent, Rodney. I do have a question. Derivative of sine is positive cosine or negative?
Oh, my bad. So
Okay, good. All right, so that's excellent chain rule. All right, good mastery of the chain rule. So now the integral of the sine of x natural log of x dx is u, which is the sine of the natural log of x times v, which is x, minus the integral of x of v, which is x, and du, our du is perfect, cosine of natural log of x times 1 over x dx. So again, if you can't master the chain rule just like Rodney did, you need to practice. Okay, he took the derivative of the outside function and then multiplied by the derivative of the inside function. So I get the integral of the sine of the natural log of x dx is equal to x times the sine of the natural log of x minus the x's cancel, and I'm going to get, oh my goodness, I get my integral back. There's the integral I've been looking for. Okay, so the cat chased its tail from cosine log x dx to sine log x dx, and then it kept chasing sine log dx, log of x, and it got back to cosine log of x. So the cat has made a full circle with its tail. Okay, so now I need to plug this into here. Okay. So I get the integral of cosine log x dx is going to equal x, nope, cosine, nope. Something's wrong. This, I forgot an x up here. My x walked away. Okay. So it's going to be x times the cosine of natural log of x plus x times the sine of the natural log of x. And then I'm going to subtract off the integral again. So now I need to add it to both sides. Okay, so I get 2 of them. is equal to x cosine of the natural log of x plus x sine of the natural log of x. And so therefore my answer is to divide by 2 to get what I need. Okay, this is x cosine of the natural log of x plus x sine of the natural log of x divided by 2. I'm done. So let's add on my constant. Okay, any questions? So those are the cat chasing the tail kinds of problems. They get harder if I have something like e to the 2x cosine 5x, because now I have derivatives flying all over the place. So their 2's and 5's are going to be all over that problem. But I now have some practice problems I want you to do. Okay, you can start working on that one. I'm going to turn off the video for a minute. The last 2 problems are as follows. So we have x cosine 2x. We found x is u, this is dv. Then we found v as 1/2 sine 2x. And we put everything in, u dv equals uv minus integral of v du. We simplified everything. We had to integrate this last integral. And we got a final answer. Then the next thing we did was, what happens if we evaluate this thing as a, what do you call it? A definite integral. So we evaluated as a definite integral. And then the last thing that we did was we did the last problem, but we used a table. And so we found x cubed, 3x squared, 6x, 6 and 0 as our derivatives, and sine 5x minus 1/5 cosine 5x, minus 1/2, there, 25 sine 5x. So we found all the integrations, and then we put them in, and the only thing left to do is to simplify them, but we're out of time. So plus C. Okay. Thanks, guys.
Have a good day, Professor.
You too.